Hi guys, today we are going to see a very useful transformation. That is, we are going to convert a network of resistance in delta form and change it to a star form. As you can see, the triangular shaped with resistance A, B, C, this network is our delta network, and the one with resistances P, Q and R, we are calling this the star configuration. Now if you want to change delta to star, we need to know what will be the value of PQR in terms of A, B and C. A very useful trick is that you find out the equivalent resistance between 1 and 2, 2 and 3 and 3 and 1 in delta configuration, and that should be exactly equal to the equivalent resistance in our star configuration. Okay, so we are going to exactly do that. So equivalent resistances. Now let's see between 1 and 2. In our delta configuration, the equivalent resistance between 1 and 2, that means if the current has to go from 1 to 2, then you can see there is a resistance A which is in parallel with a series combination of B and C. So equivalent resistance in delta configuration between 1 and 2 will be a parallel combination of A with series combination of B and C. So we have A times B plus C divided by A plus B plus C. Here I am using the parallel configuration formula that R1 R2 divided by R1 plus R2 is the equivalent resistances in parallel. Now that must be equal to the equivalent resistance in our star configuration, which is between 1 and 2, it seems like it is simply P and Q. So P plus Q in series. Now let's see what is between 2 and 3. Between 2 and 3, we can see that in delta configuration, C is in parallel with a series combination of A and B. So C times A plus B divided by C plus A plus B. And in our delta transformation or the configuration, let's say, between 2 and 3 we see the resistances are R and Q. Now between 3 and 1. Similarly between 3 and 1 we see that B is in parallel with series combination of A and C. So B times A plus C divided by B plus A plus C, and that must be equal to equivalent resistance between 3 and 1 in star transformation, and which is simply P plus R. Now if we look at these three equations, on the left hand side we have denominator is same, A plus B plus C. We can take advantage of this. Okay, let us add these three equations. Let's say this is equation number 1, this is equation number 2, this is equation number 3. Let's add these three equations. So the denominator is common, and in the numerator we will get terms like AB plus BC plus CA each 2 times. So 2 times AB plus BC plus CA, and that must be equal to the sum of the terms on right hand side, which is P and Q appearing 2 times, R appearing 2 times. So it will become 2 times P plus Q plus R. So we can see that after cancelling 2 we have AB plus BC plus CA divided by A plus B plus C will be in this case equal to P plus Q plus R. So let's say this is our fourth equation. Now our delta to star configuration, now our delta to star transformation requires that we get the value of P, Q and R separately in terms of ABC. So if we want the value of P, you can see that if we subtract equation 4 from equation 2, so we have 4 minus 2, we can get on the right hand side the value of P, and on the left hand side you can see that CA and CB will cancel out. So what remains on the left hand side in the numerator will be AB divided by the denominator, which is A plus B plus C, and that must be the value equal to P. So we have P is equal to, which is the resistance between 1 and the common node here, okay, and that is equal to product of the two resistance in our delta configuration adjacent to 1. So that is how we will memory map it. So adjacent resistance are A and B, so it is AB divided by A plus B plus C. Now let us see if it is repeated, if this pattern is repeated for Q as well. So if you want Q, we'll have to subtract 4 with third equation. P and R will cancel out and we'll get our Q equal to, and on the left hand side you can see in the numerator AB and BC will cancel out. What remains is CA divided by A plus B plus C. Now as you can see, for Q is the resistance between 2 and the common node in star configuration, and it is given by product of C and A, which is adjacent resistance to 2 in our delta configuration. So our memory mapping works. So now if you want R, you can similarly do 4 minus 1, and as we have already understood the pattern, it will be equal to R will be equal to, R is the resistance between 3 and the common node in start configuration, and that must be equal to the product of adjacent resistance to node 3 in delta configuration, which is B and C. So it will be BC divided by A plus B plus C. So guys, we have our equivalent resistance PQR in terms of A, B and C. So now given a delta configuration, we would be able to convert this into star transformation. We'll see the application of this method in my coming videos. I hope you enjoyed the video. If you did, please like and subscribe. Thank you so much.